Angular momentum is defined as the quantity of rotation of a body, which is the product of its moment of inertia and its angular velocity. The moment of inertia is the measure of the resistance of an object to changing its angular speed. Angular momentum is determined by an object's mass, its velocity, and how far the mass extends out from the point of rotation. The nearer the mass is to its axis point, the greater its velocity. A good example of angular momentum in gymnastics is the Tkachev on uneven bars, where a gymnast rotates around in one direction and at the point of release needs to be rotating in the other direction in order to recatch the bar again. In order to successfully catch the bar, gymnasts need to use angular momentum to create the trajectory of the center of gravity to allow them to be in the right position and distance away from the bar to re-grasp it. The use of angular momentum can also be seen during the functional phase of the tap, which drives the long swing on the high bar. The joint kinetics during the power phase and the forces around the hips, knees, and shoulders provide the input of energy which allows the gymnast to create the angular momentum during the swinging phase. Angular momentum provides gymnasts with the ability to execute skills of rotation critical for success within artistic gymnastics. The following video displays a gymnast completing continuous bounces on a trampoline, where momentum is produced through the tuck phase during the rebound. This example of angular momentum results in an increase of height and the ability to then complete additional twists and rotations. Similarly, video 2 displays angular momentum as the gymnast tucks in her knees, bringing her mass closer to the center of the axis of rotation, thereby decreasing the moment of inertia. When the gymnast decreases her moment of inertia, her angular velocity increases proportionally. Sport-specific examples of angular momentum which result in the success of gymnastic skills include the front handspring tuck, front tuck, and layouts on the floor exercise. Examples on the uneven bars include front hip circles and glide kips, where the gymnast shortens their body and in turn changes the distribution of their center of gravity. Additionally, the use of angular momentum is evident during the transition phase of a back handspring to a back layout step out on the balance beam. The angular momentum is conserved in the gymnast even though her legs and her body move at different speeds throughout the jump. The momentum is then transferred from one body segment to another, so the total angular momentum of the system is conserved, allowing gymnasts to stabilize their center of gravity and therefore execute the skill effectively.